Okay, before we left, we talked about how to make this plot. It's called a bar plot. Don't confuse it with a histogram. And R is very easy to understand. It's just like speaking a language. We have said ggplot is what is the package used for visualizations. Then here we are using a bar plot. You can see it has clearly defined it here as geom underscore bar. Then we wanted to make this color to look very presentable, so we used blue. We said cornflower blue, field cornflower blue. Then we wanted the borders to be seen clearly. We labeled them with black color. Then we gave our graph a title. Then we gave our graph an X label and a Y label. We used labs for that. Maybe if I can add on something. What else can I add on this graph? Let's say I want to add the numbers here. I want this graph to have numbers, each bar to show the number of participants. So to do that, what you'll do, you'll add geom. These are functions within ggplot. I'll use geom text. Then I'll say aesthetics is equals to label equals to n. Then I'll do something called vjust. I'll give it a value of 0.5. Let me see if that works. There is some problem. Let me read it. I'll add something here on the aesthetics. I'll say y is equals to n. Y is equals to n. Then geomba, it's there. Then I'll say start is equals to identity. I think if you add that will work now. On geomba, start equals to identity. Then on geom text, we have aesthetics label given by n, then we just that one. Let's try it out. Still not working. Where is the error? Maybe there is a package that I've not downloaded. There is always this package named scale, library scales. Then let's try run it out. It's not working. Okay, guys, I'll update that on our next class. I think I missed the code here. Geomba, because the following missing aesthetics. Where is it? Geomba field color starts lab X frequency field cornflower blue marriage aesthetic geomba field is equals to cornflower blue. Then we can remove this since we are now not working with it. And we now have that output. Okay, I'll show you guys how you can add values here on top of these bars to represent the frequencies. You can see from this, maybe it can be difficult to read what value is this one, what value is this, what value is this. So I'll give us that option of adding values on top of this. I'll update, then I'll give you the feedback. Probably when you check on the link that I'll send you to find this code, it will be already updated. Okay, we'll move to the next univariate graph, which will be now for this was for categorical data. Categorical data. We'll now now look for numerical data. Numerical data will probably use a histogram. We'll use a histogram. So let me delete this one. I'm still using the marriage data set. Remember, it's a single variable plot, a univariate plot. We'll still call it ggplot. Then data, your data now is marriage. Then the aesthetics, which we label our X now to be equal to a numeric data within our data set. Here is, we have age. Then after that, you do just similar process. You come here, you now add the type of graph you want, which will now be geom hist to mean histogram. You can use even, then you can run this and see what it outputs first. Then we can add those other. You can see this is our output. It doesn't look very much appealing, so we can do those other alterations to make it look cool. So we'll do fill. I love blue. I'll use cornflower blue. Then we'll do color for the borders of those beans. Remember, these are called beans. Color is equals to, I'll label it black. Let's run that and see what. We'll also add the labels so we don't have to repeat everything. X is equals to, our new X now is age. Here we want to study the distribution of age in our population. Then we'll add a Y variable now. We'll say Y. We'll still name it as frequency. We can leave it at count, but let's use frequency. Then we can give our graph a title. Let's say participants by age. Then we can, what else can we add? Let's add a subtitle. Distribution. If you run this, we should now have an updated graph. You can see these are the beans. They are now colored blue. Then we have, they are bordered with black. Then we have a subtitle and our title, X axis name, Y axis name. What else can we add here? These beans are quite numerous. We can use few beans. So to use few beans, you will specify here. You will say bean. Still on the geom histogram, say beans is equals to, let's say we want 10 beans. Let's run. You can see the number of beans are now reduced to 10. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And how do you describe now your graph? Here we can say that just by studying these bars, you see this one, it has the highest, it is the longest. This is to mean that people within the age bracket of 20 were the majority in this study, and people in the age bracket of 80 were the minority. That is how you translate your graph. Then there is also something we can add. Here you can see these things are conjoined, these bars. So we would like to have a space in between. So to do that, say we'll do what? We'll say bin width. Bin width. Bin width is equals to, let's place it at 1. Let's try to run that. You can see it has provided some bin width, but it's not looking quite good. You can see it. So maybe you can opt to just have the bins and remove that. Remember, in visualizations, it's just upon you to make your visualizations look appealing, something presentable you can show to people and explain to them. For categorical data, where we used bar chart, then we have looked for numerical data where we used histogram. Now we'll move to bivariate graphs. Let me just uppercase this one. Bivariate graphs. I might be very fast in this other session. Bivariate graphs. Remember, we have said bivariate graphs is for plotting two variables. You try to relate the relationship between two variables in a single plot. So we can use a stacked bar chart. For that case, I want to use a new data set here. I want to use a new data set with those entries. So we'll do for categorical. We want to compare two categorical variables. Then we'll do for numerical. Then we'll do for those two conjoined, categorical and numerical. Okay. So the first bivariate graph I'll discuss with you guys, it's for categorical versus categorical. Remember, we have said bivariate, it's for two variables. So let's say you want to find the relationship between a categorical variable with another categorical variable. I've said I'll use some new data. You can use these data sets that I'm using for your own practice. There is this data always called MPG. MPG is a data about car fuel consumptions, different cars. Maybe we can view it first and see what it entails. MPG. It's within some library in R. I think it's within ggplot2. Yeah, it's within ggplot2. So let's first learn how to call it from ggplot2. You will say data, just as in the first case. Then you will say, you'll name your data, then identify the package. Which in this case now is ggplot2. And just mpg down here and find some output on the console regarding the data. MPG. Is it not running? Wait, that one. That. And see, here on the console, we have this MPG dataset. It has manufacturer, these variables, manufacturer, model, display, year, cylinder size, transportation. We have auto manual, think type of car, then drive. Is it a, how do we define this? Is it a front wheel drive? Is it a four-wheel drive? They're up to, I think, 3 classes. They do have 3 classes. Then we have rear. Okay. Now we have our data in our working space. So we want to try to plot a bivariate graph relating to two variables. So I'll do for class, then I'll compare it with this one, drive. So to do that, just start as usual ggplot. Then you call your data. Our data is now mpg. Then the aesthetics. On aesthetics now we have x is equals to plus. Then we can do fill equals to our other variable now, which is drv, type of drive. Then we can now add our graph. The graph now we want, the graph that we want to display now. So we'll display a geom bar still. I've said we're going to do a stacked bar chart, a geom bar. Then within it, we'll give it this argument, position is equals to stack. Let's see what that does. Yes, you can see here on our windows, you can see this graph. It compares two entries, which is the class of the car. Then these colors now represent the type of drive. Remember, I told you guys we are comparing the class and the drive, the type of drive. So we have two-seater. Two-seater has the drive, the rear wheel drive. We can see that most of two-seaters are rear wheel drive. Then if we come to compact, it has four-wheel drive and front wheel. This is for front wheel, this is a four-wheel. So most of compact vehicles are front wheel in our study here. Then few of them are four-wheel. Then for mid-size, you can translate them just as similar as we have translated this. Then for minivan here, they're saying for minivan, most of them are front wheel. Then you can see for SUVs, most of them are four-wheel drive, but few of them are rear wheel. So that is how you can plot a stacked bar chart. Let's give it some names. Let's give it some title to make it easy to understand. So we'll say, no, to add titles, you use labs. Then our X now will be the class. Then our Y now will be, let's just label it as count. Then our title is equals to cars, class, car class, says drive, type of drive. That is just a sample name. It's not a good one, but I think it works. So that is how we compare two categorical variables. Remember, here in our data, you can see drive, it's indicated with FF4. These are, we can describe them as ordinal variables. Remember, we have nominal and ordinal categorical variables. So for our case here, drive was an ordinal variable. Then we have class. Class, we have compact, mid-size, two-seater, minivan. They're also ordinal categorical data. So that is how we compare two categorical data. Then we can do another one for now, numerical versus numerical. This one we'll use ggplot. We'll use scatterplot, I mean ggplot. Then still we can use the data mpg are continuous. We have cty and hwy. So let's try inserting them. So we'll say our data is mpg. Our aesthetics, we'll say x equals to, first one we have said we have cty. Then we can say y is equals to class. Then 0 point. Let's see what that outputs first before we can tweak it. You can see this as a scatter plot, but our points are not that interesting. They're not that interesting. So maybe if I can source some other data, or maybe you can now use let's try the insurance data. Insurance data has these entries. We have BMI. Let's compare BMI with charges. For BMI in our x-axis, then charges to be on our y-axis. Let's run that. You can see this one now looked, yeah. We have BMI and our charges. We can also tweak this one to appear very nice. We can do that but I think we can discuss that one we can discuss it in our other sessions. Time is not on our side. Maybe we'll also discuss the multivariate graphs in that other lesson. For now, I'll invite Jeremy to maybe talk on data cleaning methods and other stuff. So guys, in our next session, I think we'll still be on data analysis. I'll do this visualization bit to the end. I'll discuss the multivariate graphs. We'll also try to tweak this one to make it look presentable. Okay, thank you. Jeremy, you're now welcomed.
Thanks very much. For those who don't know me, my name is Jeremiah Katumo. Previous classes sijakuwa nikiwa around, so in this class niko around, and we shall be talking about data analysis with R. Maybe let me recap from what my colleague has said, what he defined data analysis. Data analysis is a process of inspecting, cleaning, transforming, and modeling data with the goal of highlighting useful information, suggesting conclusions, and supporting decision making. So as we can see, data analysis has various processes, which you have first to clean the data before you do your analysis. Cleaning the data is the most important step before starting an analysis. And to be true, data cleaning is the most time-consuming process. So in this session, I'll be taking you through data cleaning. And data cleaning, before I talk about data cleaning, statistical analysis is divided into 5 steps. That is, first you obtain the raw data, then you have to check for some normalization, turn it into a technically correct data, then maybe do some imputation in the data to obtain consistent data. So data cleaning is the process of transforming raw data into consistent data that can be analyzed. And today, we are going to talk about transforming a raw data into consistent data. What we mean by raw data is data that may lack maybe some headers, can contain wrong data types, maybe they can contain wrong category labels, can also have unknown or unexpected character encoding, maybe, and so on. So turning raw data into consistent data. What do we mean by saying we are turning some data into consistent data? Consistent data is the stage where data is ready for statistical inference. It is the data that most statistical theories use as a starting point. So maybe before we proceed, I don't want to hear if someone has a question. Any question?
Hello, Jerry.
Yes.
Could you please share with us your screen? We can't see the slides.
You heard the slides, man. You didn't send me the slides.
I didn't send you the slides, but I sent them on a WhatsApp. Yeah. Let me resend them.
Through email.
Okay, no problem. Share your screen for whatever you're presenting, or let me make you a host.